Hey guys, so today we're going to go through section 6.6. Just go through the last two problems in the notes. Numbers 3 and 4 were kind of close to the end of class yesterday, so I figured I would recap and do them. If you need to hit pause and look at numbers 1 and 2 again, I have the work there for you. So let's get started with number 3. So v equals 1/3 s squared times h, and we're solving that for h. So we're solving it for this guy here. So we need to get rid of the 1/3 and also the s squared. So a few people in class divided both sides by 1/3 s squared, but let's first get rid of this 1/3 by multiplying both sides by 3. So 3v equals s squared times h. And then to get rid of the s squared, since multiplication is between s squared and h, we're going to divide both sides by s squared. Your s squareds cancel, and you're left with h equals the left-hand side of the equation. So this will be your final answer for h. For those of you that divided both sides by 1/3, you would have v over 1/3 s squared. When you have a fraction in the denominator, you need to simplify the coefficient, so you need to, when you divide by a fraction, you multiply by the reciprocal, so that's what makes the 3 come up to the top. Number 4, solving for little r. So put parentheses around r plus r. To get rid of that in the bottom, we're going to multiply both sides by r plus r, so I times r plus r equals e. Here is something that we need to be aware of. We are looking for isolating r, and there's only one of them. So since there's only one, we can first get rid of I by dividing both sides by I. And once you get rid of I, you're just left with r plus lowercase r equals e over I. And to get rid of capital R, we subtract it on both sides, so r equals e over I minus capital R. If r is in multiple locations, meaning one on the right and one on the left here, then we would have to distribute the I. And if you did distribute I, another answer that you could have gotten for number 4 would be e minus I r all over I would be another answer that is fine to have. I always try to do the least amount of steps, so that would be the one in the denominator. Notice here, how would you get that? Putting both of these numerators over I individually, that's where the i's would cancel and you're left with r by itself, in case you were wondering. All right, number 5. We are searching for t, and t is in 2 spots, here and here. So we're going to move any term that has t to one side and anything that does not have t to the other side. So let's move our t terms to the left. So at is already here, and we're going to move bt over by subtracting, and we still have 3, and we have a negative 4b. Now we're going to move 3 over, so we have at minus bt equals negative 4b minus 3. Now, 2 terms on the left have t in them, this one and this one. What operation would allow you to take t out of both of those terms? Think about which property allowed you to have t being multiplied to multiple terms. If you said the distributive property, you are correct. So the inverse of the distributive property, since that was multiplication, you're going to divide out t from both terms. And me highlighting that in yellow kind of makes it nice, because when we factor out a t, meaning divide both terms by t and just place it right outside here with parentheses, what is left over is the coefficients a minus b. If we were to distribute this back, we would get a times t and negative b times t. Order does not matter for multiplication because it's commutative. So TA is A times T, and negative B times T is negative BT. Now we have T in one location instead of two, and the operation between T and A minus B is multiplication. So to get rid of A minus B, we're going to divide both sides by A minus B. So T equals negative 4B minus 3 over A minus B. And that is the final answer. Remember, it doesn't matter how ugly the one side gets as long as we isolate the variable that we are looking for. So likewise, number 6. Take a minute and in pencil try to write what you think you need to do in order to solve this equation for F1. Notice that addition messes it up. We can't cancel stuff because the denominator is in parentheses there, F1 plus F2. All right, so to get rid of F1 plus F2, look right up at number 4 there. We multiply both sides by R plus R to get to the left. So number 6, we're going to have F and then F1 plus F2. That was by multiplying both sides by the denominator equals F1, F2. Now we're still looking for F1 and it is in the parentheses and outside the parentheses. So when that happens, we need to distribute this F. So I have F, capital F times F1 plus capital F times F2 equals F1, F2. I'm continuing to highlight just for us to see what we're solving for. Now we have only one term on the right, and that is one of the F1s, and FF1 is on the left. So let's move him to the right. So we have F, F2 equals F1, F2 minus FF1. Now our F1s are on the right. And just like over here in number 5, we had two terms with T, what will we need to do in order to get F1 by itself? If you said factor, you are correct. So F1, in parentheses, we have F2 minus capital F, and FF2 is on the left. And what operation do we need in order to get rid of the F2 minus F right here? If you said division, you are correct. So F2 minus F would eliminate it. So we have F1, which was on the right, equal to F, F2 over F2 minus F. Final answer. I know that these are challenging. Take it slow. Always come back to this video when you need to. And let me know if you have any questions. Thanks, guys.